Hello, we have done the design of the module of the end gate. We have also simulated the end gate. So now is the time that we go for the actual implementation or programming our board. So if you focus on this flow navigator chart, so the Vivado has actually streamlined the design process. So we have covered basically the main options into the project navigator where project manager, where basically your all design files and in the simulation files are. So the second thing then we have covered was a simulation tab that we have done as well. So let's skip for IP integrator for now. And for the next step would be to do the synthesis. So the second thing that you want to do now is run the synthesis. So synthesis is basically just like a compiling a code in other languages. So let's do the synthesis of our program, and let's click this run synthesis button. And so for example, we say so that option was basically was telling me that you're doing the synthesis again. So I cancel that, but you'll not see that option. So if you see here that you can see that the Vivado is basically running the synthesis design, and there are some tasks related to the synthesis that are done by the Vivado. So once the synthesis is done, so then we will do the implementation. Then we'll run the implementation. And the good feature of the Vivado is that it guides you basically by the step by step through these processes. Okay, so we'll not go into the details of each process for now at this moment, but so you follow these steps. So once this is done, it will then give you the option to run the implementation there. Okay, so when you run the implementation, then it will basically actually then we need to it will ask us for creation of the constraint file. So the constraint file is basically where you actually make the connections to the actual pins of your FPGA. So let's wait for this synthesis to complete, and we'll continue. This will take some time, sometimes around a minute or so. So we'll continue once the synthesis is done. We'll see from here. Okay, so it's done. So now it gives us the option for synthesis is complete. So do you want to say the next is to run the implementation? But then we run the implementation. We do not want to use the previous implementation. So let's do the implementation. So again, you'll see here that the implementation will be, process will be started. So let's wait for that to be stopped, to be completed. And then so after that step we'll define the constraint file. So meanwhile this implementation is being completed, I want a little bit talk about the board real quick. So this is our Basys 3 board that we are going to use. So this is the point of the programming where this is called the programming board. So it's in our documentation. It's called the JTAG USB port. This is where you will connect through USB cable from the computer to this board in order to program this. And make sure that you turn on the switch. So this switch is turned on and off for this board. So turn on the switch if you want to program this. So what we want to do is that we want to use these two switches as an inputs for AND gate module, right? And we want to use, for example, so let's use this LED as an output to the AND gate, right? So important thing here is that you want to know is where these inputs and LEDs are connected. So this is our main FPGA board, FPGA chip, where everything is connected and everything will be processed. So we want to know where this switch is, to which pin this switch is connected, and to which pin this LED is connected. And so we have basically we were going to implement AND gate inside this chip. So So the good thing about the Basys is that they have already given the location of the switches. So for example, the location of the switch is connected to the V17 pin. So this switch is connected to V17, and this switch is connected to V16. And this LED is connected to E19. So these are the pin names that we have to specify that we are connecting this particular switch and this particular LED to the physical pins, right? So take a note of these pin numbers, and we are going to write that into our next step. Okay, so let's come back to the Vivado. And so this is basically saying that our implementation is complete, and so now it is saying that you want to open the implemented design, or you want to generate the bit stream. So bit stream is the final file that we want to download. So but before we download or download this document, and we are basically we want to specify the pin names, right? Okay, so when you click open, then it will open some tabs over there. So one tab that we are interested in is the package. So this is the chip that you are seeing. This is the backside or internal uh, diagram of the chip that I just showed you. So if you want to really do the connections to the end gates, you will go here, which is the I/O ports, and this is where you specify that which pin is connected to what. So we have implemented an AND gate inside it, and we just want to do the connections. So if you click the scalar ports, then you'll see that you have an output. This is randomly assigned to the pin, so we want to assign our. So for example, output was our LED. So we want to specify it to E19, and our input was V16 switch and V17 switch. So this is specified, and one thing that you want to specify more here is that because Vivado uses, Basys 3 uses the 3.3 volt reference source, so you want to you set this as a LVC CMOS 33. Okay, all set. Then click save, and this is going to ask you to save this file. So let's save this file as a test, and this is a constraint file here. So let's just a reminder. Okay. So if you save it, then this will be saved into your project as well. And this is very interesting in the sense. Let's have a look at this before we actually go to download this. So if you go to your project navigator, and you'll see this constraint file there. So let's see what's inside this. So as we get more experience with this, then we will be actually writing this constraint file rather than selecting the pins from the I/O planning. So you can see we have set this is a simple property set that we are setting. So we are setting the property we are is a 3.3 volt, and we are setting the LED. So let me set first the properties just to make sure the properties are defined well, and then we'll define the connections. Switch 1 is connected to the V16, switch 2 is connected to V17, LED is connected to the E19. Okay, so all set. So let's now go towards, so we have done the synthesis, we have done the implementation, and now we want to generate the bit stream. So when we define the constraint file, we basically modified the implementation. We want to rerun the whole process. So when you click the generate the bit stream, it's going to run all the necessary processes that are needed. So because we only defined the connection, so it's now running the synthesis again. It will run the implementation again, and just to make sure that every connection is right, and then we will download it into our boot. So let's pause here, and we'll continue when it's done. So while this is running, I want to show you the camera view where my board is connected. So this is our Basys 3 board. So if you can see my programming, So it's the programming port is connected. I have turned on the switch. So this is basically the default program that's running onto the chip, which is basically incrementing all the 7 segments. So what we are expecting here is that when we will turn on the switch, this LED will glow. Okay. So right now it doesn't have this feature. So right now it has the default program that whenever you turn on particular switch, it turns on the LED just above it. So it has a default program that is implemented. So, but when we will implement our design, this whole thing will get changed. Okay. So let's see where we are doing with that. So we are still running the synthesis. So the um, synthesis process takes time usually. So depending upon the complexity of your design. Okay. So this is done now. So let's open the hardware manager. So you can open from here as well. So once the bit stream is generated, you can open the hardware manager from here as well. So let's open from there. So once the hardware manager is open, you may want to auto connect and want to look for what hardware. So you let Vivado to look for the hardware that are connected to your PC. Um, so it is automatically going to search for the different hardwares and will show you the board. Okay. So it found this board, so which is the RTX 7 board 835 that we selected in one split, the Basys 3 board, which is inside the Basys 3 board. So let's go ahead and click this program device, and it will ask you the confirmation which bit stream do you want to program. So let's program this. So it says that the bit stream is run. So let's open our camera. Okay, so you can see that everything is stopped. So let's see we test that whether AND gate is implemented on these two switches and this LED, which is the second one. So 0, 1, 1, 0, 1, 1, and you have implemented AND gate. I hope these tutorials are helpful. So good luck with your designs. Thank you.